Okay, for example 3, notice this time we got a mixed number times x equals 3. It says what number is being multiplied by x? That's 2 1/4. But then it says write it as an improper fraction. Improper fractions are much easier to work with than mixed numbers when it comes to solving equations. So I'm going to rewrite this as 9/4. Keep in mind, 2 times 4 is 8 plus 1 is 9. That's how you create the numerator, and it goes over the same denominator of the fraction. So 9/4 is equivalent to 2 1/4. That transforms the equation from what it was, 2 1/4 x equals 3, into 9/4 x equals 3. I would probably put the 3/1 just to create that fractional structure. And now it's exactly the same difficulty level as the last problem was. We have a fraction, that is the coefficient. We're going to multiply both sides by the reciprocal. So 9/4 is the number that we mentally thought of in step A. The reciprocal of 9/4 is 4/9. We're going to multiply left side and right side by the same amount. On the left-hand side, the 9's divide out completely, the 4's divide out completely. So altogether, the fraction multiplication creates a 1 coefficient, so we get 1x equals. Over on the right-hand side, 3 times 4 on top is 12. 1 times 9 on the bottom is 9. So x equals 12/9. That happens to reduce to 4/3. I do want, again, a reduced fraction always. I'm not going to count off at this point for not reducing a fraction, but it's just good practice, good habits. At some point I do get a little bit more picky about reducing fractions, so create the habit now, reduce whenever possible. One shortcut, when you are multiplying fractions, if you notice before you multiply that you have reducible stuff going on, you can do that then. So 3 and 9 both divide by 3. That leaves 1 times 4 on top, 1 times 3 on bottom, gets you directly to the reduced form. It's not a requirement to do it that way, but sometimes when the numbers get much larger, it makes it easier to reduce while they're still in the smaller form before you multiply.